the end of a star's life. While stars come in a wide variety of different types, one thing they all have in common is that their days are numbered. Every star will one day meet its end when they run out of fuel. In the case of a star, that fuel comes in the form of hydrogen that is fused together in a star's core to produce energy. Once a star begins to run out of hydrogen fuel, it will enter the final stages of its life cycle. How a star evolves will be dependent upon its mass. High-mass stars will explode as mighty supernovae, while lower-mass stars will swell into red giants, eventually blowing off their outer layers. Our Sun, which is a middle-mass star, will eventually run out of hydrogen and evolve into a red giant. It will swell many times larger than its original size, and may even become large enough to devour the Earth. Kepler's 1658b is currently orbiting a star that is entering the red giant phase, and its days are numbered as a result. A glimpse of the future. Kepler's 1658b potentially offers us a glimpse of the future of our own world. Since the host star of Kepler's 1658b is similar to our Sun, the fate of the Sun will likely be analogous to that of Kepler's 1658. As the Sun eventually evolves towards becoming a red giant, it will likely engulf the orbits of Mercury, Venus, and perhaps even Earth. By observing worlds like Kepler's 1658b, we can get some kind of idea as to how our solar system will evolve as the Sun enters the final stages of its life. Like how Kepler's 1658b will be devoured by its star, Earth will likely be engulfed by the Sun when it runs out of fuel 4.5 billion years from now. When was the first exoplanet discovered? Astronomers have confirmed the existence of over 5,000 exoplanets in our galaxy alone, and every year that number increases. Interestingly, the study of exoplanets is a fairly new area of astronomy, with the first planets beyond our solar system discovered in 1992 and the first true exoplanet having been found in 1995. How were the first exoplanets found, and what type of planets are they, the first alien worlds? It is important to note that the first planets found beyond our solar system are not technically defined as exoplanets. The term exoplanet means extrasolar planet, meaning it is a planet that orbits a star other than our Sun. However, the first planet found beyond the solar system was discovered in orbit around a neutron star, a stellar remnant that is not defined as a true star. Rather, neutron stars are the leftover remains of a massive star that went supernova, leaving behind an ultra-dense core of neutrons. Throughout the 20th century, there had been some hints of evidence of exoplanets, yet none were confirmed. The first official confirmation of a planet orbiting something other than our Sun came in 1992, when a team of astronomers detected 3 planets orbiting the pulsar PSR B1257+12. At the time, this was a rather remarkable discovery. Not only had astronomers proved that planets did in fact exist beyond our solar system, it also showed that not every planet orbits a star. Pulsars are a type of neutron star that spin rapidly about their axis, and they generally form from the gravitational collapse of a massive star. However, if PSR B1257+12 had in fact formed from the collapse of a star, it is extremely unlikely that any planets would exist. When the star went supernova, the resulting explosion would have obliterated any orbiting worlds, and astronomers eventually came to the conclusion that PSR B1257+12 likely formed from the merging of 2 white dwarfs rather than the collapse of a massive star. 51 Pegasi b. Although the first planets beyond our solar system were found in 1992, they orbit a pulsar rather than a main sequence star. Since one of the primary reasons behind the search for other worlds is to find potentially habitable planets, astronomers must find planets that orbit stars. Only 3 years after the discovery of 3 planets around PSR B1257+12, astronomers confirmed the existence of a planet orbiting a Sun-like star called 51 Pegasi located a mere 50 light-years away. The planet, designated as 51 Pegasi b, was discovered using the radial velocity method. This method relies on although the first planets beyond our solar system were found in 1992, they orbit a pulsar rather than a main sequence star. Since one of the primary reasons behind the search for other worlds is to find potentially habitable planets, astronomers must find planets that orbit stars. Only 3 years after the discovery of 3 planets around PSRB 1257+12, astronomers confirmed the existence of a planet orbiting a Sun-like star called 51 Pegasi located a mere 50 light-years away. The planet, designated as 51 Pegasi b, was discovered using the radial velocity method. This method relies on although the first planets beyond our solar system were found in 1992, they orbit a pulsar rather than a main sequence star. Since one of the primary reasons behind the search for other worlds is to find potentially habitable planets, astronomers must find planets that orbit stars. Only 3 years after the discovery of 3 planets around PSRB 1257+12, astronomers confirmed the existence of a planet orbiting a Sun-like star called 51 Pegasi located a mere 50 light-years away. The planet, designated as 51 Pegasi b, was discovered using the radial velocity method. This method relies on the galaxies. A galaxy is an astronomical structure containing millions to billions of stars, gas, and dust bound together by gravity. Interestingly, there is no agreed-upon definition of what a galaxy is. Even with the definition provided above, there is no distinction between a galaxy and a large star cluster. For the purpose of this discussion, we will consider the defining factor of a galaxy to be the existence of multiple generations of stars, mainly because this is something that star clusters generally lack. Thus, we can define a galaxy as an astronomical object that contains millions to billions of stars from multiple generations, all of which are bound by gravity. Galaxies and the Great Debate. Less than a century ago, our view of the universe was radically different than it is today. Before the late 1930s, it was widely held that the universe was composed of nothing more than the Milky Way galaxy and the stars and planets contained within it. The rest of the universe was infinite and static in its expanse. Today, however, our universe picture is far different from this. We now know that the universe is not static and that it is, in fact, home to hundreds of billions, perhaps even trillions, of individual galaxies. This view of the universe first came to light in the late 1920s, when astronomer Edwin Hubble made a remarkable discovery using the M.T. Wilson Observatory. Using what was one of the most advanced telescopes at the time, Hubble sought to determine the distance to what were believed to be stellar nebulae. Nebulae are vast regions of star-forming material that exist throughout the Milky Way. Before the 1920s, astronomers thought that what we now know as distant galaxies were nebulae within the Milky Way. The nebulae that Hubble was interested in were a subject of intense debate in astronomy, as different groups of astronomers debated what precisely these objects were. Known as the Great Debate, astronomers discussed whether or not some of these distant nebulae were other galaxies or star-forming regions within the Milky Way. Most astronomers believe they were distant nebulae contained within the Milky Way, but Hubble sought to find out indeed.